Hello, professor and classmates. We are Team SQL, which stands for Sweet and Quality Food Lover. Our team members are Brandon, who loves Korean BBQ, Hoon, a hamburger enthusiast, Emily, a macaron lover, Sanya, who enjoys dumplings, and Yuna, a chocolate killer. As you might have guessed, we introduced ourselves with food because it relates to today's data set. There is a saying that the biggest innovation brought by smartphone is the invention of online food delivery apps. Most of us have used Uber Eats or DoorDash, and food delivery apps are now a global trend. When choosing a database analysis topic, we wanted something relevant to our daily lives and modern business trends. That's why we decided to analyze an online food delivery app database. We found a Zomato dataset on Kaggle, an India-based food delivery platform, and began our Zomato project. Let me briefly introduce Zomato. Founded in 2008, Zomato is a leading online food delivery platform based in India. Before diving into our analysis, we asked ourselves, who can benefit from analyzing the Zomato database? First, food delivery platforms and restaurants, such as DoorDash and Uber Eats, can use our data to improve recommendation algorithm and enhance user experience. Next, the tourism and hospitality industry, including TripAdvisor and Airbnb, can leverage our data to provide real-time restaurant recommendations for travelers. Lastly, AI and data analytic companies like Google can enhance Google Maps food recommendations by integrating restaurant ratings and user feedback. Now, let's move on to our main analysis with Emily.
Then I will introduce the five key entities in this database: food, menu, restaurant, users, and order. The food entity represents the menu items, while the menu entity is the restaurant's complete offerings. The restaurant entity includes a business and a Zomato, and the user entity contains some basic information of people who place an order on Zomato. And lastly, the order entity links users and restaurants, ensuring the smooth transactions and timely deliveries. And let's dive into the metadata of each entity. Every food item in the system has a unique attribute, a food ID. And also list entities include name, classification of vegetarian or non-vegetarian, and allergy information, and also the number of the ingredients and the food or the beverage. Next, let's move to the menu entities. List entities contains a unique ID for the menu ID, restaurant ID, and food ID. And it also includes the cuisine type like the Indian, Chinese, or Italian, and the prices. Next, let's see the restaurant's entity. Each restaurant is uniquely identified by a restaurant ID and ensuring the current tracking and management. And this entity includes the essential attributes like restaurant name and city, rating and rating count, cost, cushion type, license number, website link, and address. Next, let's see the user entities. It stores some essential information of users. So each user is uniquely identified by the user IDs to ensuring the proper account management, and other key attributes include username, email, passwords, age, gender, marital status, occupations, and monthly income. The last entity is order entity, and every order is assigned an order number, date, user ID, restaurant ID, sales quantity, and the sales amount and the currency type to ensure the currency billing. Next, let's look into the ER diagram.
Here we present our ER diagram for our entities, which we created in MySQL Workbench. As you can see, we list the entities, their attributes and data types, and the relationships between the entities. Now I will explain the relationships between the different entities. First, in the user order relationship, A user can place 0 or many orders, while an order can be placed by exactly one user. In the order-restaurant relationship, an order is sent to exactly one restaurant, while a restaurant can receive 0 or many orders. In the restaurant menu relationship, a restaurant offers one or many menus, and a menu is offered at exactly one restaurant. Lastly, in the menu-food relationship, a menu can list exactly one food item, though a food item can be listed on one or many menus. As a remark, the last relationship may not be intuitive, but it is indeed represented by the dataset. Additionally, you may have noticed the presence of foreign keys in our diagram. Whether the foreign keys act as identifiers or not is reflected in the line for the relationship, being either solid or dotted. On this slide, we have a recap of the relationships I described earlier. Moving on, I will now describe our business rules. For our data model, we have the following. If a user places an order, then the order must be placed with a restaurant. If a restaurant does not have food, then it cannot have a menu. If a restaurant does not have a menu, then a user cannot place an order with it. All entities must have a role in the placement of an order. A user places an order with a restaurant choosing from food items listed on one or many menus. Next, Yuna will explain our relational data model.
I will briefly discuss the relational data model for Zomato. In relational databases, primary keys uniquely identify records, while foreign keys connect tables, maintaining data integrity and clear relationships. For example, in our menu table, restaurant ID references the corresponding ID in the restaurant table, and food ID references the food table, ensuring each menu item is linked to a specific restaurant and food item. Additionally, in the orders table, user ID references the users table, and restaurant ID references the restaurant table, connecting each order to a specific user and restaurant. Looking at the as-is dependency diagrams, we noticed two types of dependencies. First, we have full dependency, where the primary key directly determines other attributes. In the orders table, we have a composite primary key consisting of order number, user ID, and restaurant ID. These three attributes together determine other fields like order date, sales quantity, sales amount, and currency, illustrating a clear full dependency. Similarly, in the menu table, we have a composite primary key consisting of menu ID, restaurant ID, and food ID. Even though menu ID exists, all three attributes are needed as the composite key because a single menu ID can be associated with different food IDs based on whether the item is a vegan or non-vegan variation. These three attributes together determine other fields like cuisine type and price, also illustrating a full dependency. The users and restaurant tables have attributes directly dependent on their primary keys, user ID and restaurant ID respectively, also illustrating a full dependency. Here in the foods table, we see a full dependency and transitive dependency together. Item name, ingredients, and food or beverage depend on the primary key food ID, but vegetarian or non-vegetarian and allergies depend transitively on the attribute ingredients. To resolve redundancy from transitive dependencies, we implement the third normal form. For instance, the food table is split into two. One containing item name, ingredients, and food or beverage directly dependent on food ID, and another separate table for vegetarian or non-vegetarian and allergies directly dependent on ingredients. This normalization makes the database more efficient and avoids unnecessary duplication. Next, Sanya will show and explain our SQL queries.
And I'll be presenting key insights derived from our SQL queries and how they can help drive strategic decision-making for our platform. Our first query identifies the top 5 restaurants with the highest order volume. By prioritizing partnership with high-performing restaurants, we can negotiate better deals, ensure supply chain efficiency, and ensure customer satisfaction. This insight helps align marketing strategies and commission structures to maximize revenue from top-performing partners. The second query reveals the top 5 customers with the highest spending. Understanding our VIP customers allows us to develop loyalty programs and improve customer retention strategies. By targeting these high-value customers, we increase their lifetime value and encourage repeat businesses. The third query identifies the most ordered food item. Restaurants can use this data to optimize their menu by promoting high-demand dishes and adjusting inventory accordingly. This would help restaurant partners to maximize profitability and improve their order fulfillment efficiency. The fourth query highlights restaurants with below average ratings. This would help us detect underperforming establishments. By identifying these restaurants, we can implement quality control measures, provide business consulting, or remove consistently poor performers to protect our brand reputation. This could enhance customers' overall experience. Our last query analyzed monthly revenue trend. This would help us forecast sales. We see revenue spikes in December and March, probably due to holiday seasons and promotions. It would allow us to allocate marketing budgets effectively and plan seasonal campaigns. By understanding revenue patterns, we can ensure financial stability and drive growth. So next, Emily will have our conclusions.
So understanding customers and supporting restaurant growth are the key to the success food delivery platform. To expand our scope, we focus on customer behavior analysis and advanced menu optimization. And through the customer segmentations, we categorize users by purchase habits for better recommendations, and loyalty programs with personalized discounts drive and repeat orders, while the churn rate analysis helps retain customers by identifying why they stop ordering. And optimizing the menus also boosts business success. So tracking food trends helps the restaurant adjust our offerings, and the inventory predictions using the machine learning models can improve the stock management and reduce waste. So by leveraging data-driven strategies, we create a smarter and more efficient platform that benefits both customers and restaurants. So optimizing, engaging, and the menu management is the future of the food delivery. Thank you.